Hey everybody, Zach here, and welcome to the second part of Lesson 27 of the RTS tutorial series. We will finish setting up our vehicle AI to get it to move to a location in this episode. That said, let's get back into the editor and let's finish this out. So having literally just hit stop record and then hit record again, welcome back into the same editor that you just saw a couple of seconds ago in the last video, or at least I saw a couple of seconds ago in the last video. Alright, so we're going to go into our ground vehicle master, and we're going to continue on with setting up our input. And our end goal for this next part is our throttle input. So we're going to grab a reference to our vehicle movement, and we are going to set throttle input. And we're just going to plug that into there. And again, we're going to give ourselves a bit of space to play with, because unfortunately, yes, we will need a bit of space. There will be a couple of things that will interrupt this. We already know one of them. So let's get that one on there right now. And that will be our current distance. And that's also the first thing we're going to calculate. Easiest way to do that, just to grab your current distance, set it there, and that will go there. The other one will be our current input, because we might want to check that later on. So we'll do current input local, and this will be of type float, and we'll just set it here. And I actually know that we're going to set it relatively close to when we are done with this, so I'm going to put it as close to the throttle as I can. In fact, it's the same input that's going to be going into the throttle directly. Alright, next thing, let's calculate this current distance. So all we're going to do is literally do what we did when we calculated our initial distance. We're going to get our current location. We're going to get not our actor's location, but our current location for our actor, and our target location. We're going to subtract it and return that difference. So we have our current location, local. We have our target location. And we're just going to subtract these from each other. And we're going to normalize that difference to give us the length or the magnitude of the difference. Vector length. And we can just plug that into there. And in fact, we'll move this closer to the set steering input, just because we can. Sorry. You know me, I like it trying to be as neat as possible so it's easy to read and understand. So this is going to calculate the current distance between the vehicle and the target location. Now, we're going to use this information for a lot of things. As you know, we're already using it to see, can we reverse towards it? We're also going to use it to calculate what distance the brakes should be applied. Actually, we will be using real brakes in this one. In an earlier version, I did it by just changing the input throttle to be, a negative number. You're going to run into issues either way. Let me put it that way. Again, there's no AI running this, so it's a bit hectic how this works. Oops, sorry, that's not right. What we're going to do is we're going to get our current distance local, and we're going to take our initial distance, and we are going to look at the difference between these two, or the magnitude of difference between these two, by looking at, the ratio difference, by looking at the float divided by float of them. And what we want to know a couple of things from this. We're going to take this value, and it's going to tell us, it's going to be part of our conditional statement for if we should be applying our brakes or not. So we'll do a float is less than, and we're going to leave that blank for now. And we're going to put a reroute into this. And we're going to drag off of here, and we are going to do a multiply, if I can drag off of this. So we're going to do a couple of things with this float return here. We're going to use it to figure out when we should be braking, which will be the value that we'll put here, so the distance from our target. And then we will also be using the information to calculate what speed our vehicle should be moving at. Also should be moving forwards or backwards, so reverse or drive. So let's calculate the forward speed first. It's relatively easy because then the reverse speed is even easier because all we do is we change that to a negative value. We are going to take our initial distance. We are going to multiply that by a float. And actually, you know what? We're going to come back to this. We'll do this in a second. I'm going to explain why we're doing it by getting to the end of it and working backwards. So what we're going to do is we're going to multiply this to a power. So we're going to drag off that pin, and we're going to put the power that we want to multiply it in by. And we have a base, and we have an exponent from which we can work. So I'm just going to drag that down there so it's a little bit neater. This area is not going to be neat, by the way. Actually, you know what? That's the neatest we're going to be able to get it. We're going to have that red pin cross it. I prefer a red crossing a green than two greens crossing each other in terms of ease of reading. So what we're going to have is we're going to have a base power. We're going to have a base and an exponent. Our base will be the initial distance multiplied by a really small number to make the initial distance value, to make the return value rather small. We will then add that number to the number 1. So it'll become 1 point something, and that will be our base. So to make this initial distance really small, what we're going to do is we're going to do 5 zeros. Make sure that's 5 zeros. Let me count this out. 1, 2, 3, 4, 5, 2, 5. All right. For some reason, it doesn't like me doing it with 5 zeros in this version, so we'll do it with 4 zeros and a 2, 5 at the end there. So we are reducing this to 1 1,000th? No, 1 millionth of the initial distance, and we're adding that to 1. That's our base for our power, for our exponent. This is where we, again, need to think about our game time. We are going to take our starting time, and we are going to get the current game time in seconds, and we are going to subtract the 2 from each other. So float minus float, and we're going to plug that into here. So this, think about it this way, it's the longer I've been driving, the more I'm pressing down on the pedal, the more time I have to press down on the pedal. So you're going to pick up speed over time. That's what this represents. Again, though, remember, this isn't tied to our game clock. We might want to consider ways in which we can do that. Well, I won't do that in this section. In a later section, this will be one of the cleanups I plan on including. Plan on being the operative word. There are going to be a lot of cleanups, so it might be one that gets cut. So it might be something you want to explore on your own prior to. So next, we need to finish setting our sort of forward vector, our forward controls. So to do so, what we need then is, well, we have our forward. We need to know, are we in reverse or not? And to do that, we're going to do another multiply. I know it might not make any sense why we're doing a multiply to see if we are reversed or not, but it will in a second. What we are multiplying it by will either be a value of 1 or negative 1. As I said, it'll be either one of those or the other. If we're multiplying by 1, it's not changing this. If we're multiplying by negative 1, then it is changing it. So instead of having an if and a branch here where we have the same calculation twice, all we do is we drag off of here and we do select float. By the way, this also works for integers as well. And we'll select let's take a look at our conditional statements, because what we're going to do is this is going to be based on is the object in front of our vehicle or behind it. So we're basing it on this return value here actually. So if you want A to be negative 1, you could drag off this not, but I don't like having extra nots tied into things. So what I'm going to do is I'm going to make my A value 1 and my B value negative 1. So forward is A, reverse is negative 1 is B. So if I want it to pick A, then I want this value to be true. So I'm just going to drag down here. I'm going to drag this way actually. I was going to put the reroutes in early, but it wasn't going to let me. I can tell when it's going to do some weird things. I'm going to just put the reroutes there. But put another one here because I know I'm going to need 2 in there at least. There's no neat way to do this. I have to move all these pins and nodes and things. Yes, I'm whining. All right. And let's just clean this up a tiny bit. In fact, actually, let's drag that up there, because that's all that's really doing is going up there. And let's drag these pins to about there. There we go. So now we have said, you know, if it's in front of us, pick A. If it's behind us, pick B. So we're converting this number either into itself or into a negative or inverse value. Next, well, we're almost pretty much done, actually. So next, what we want is we want to see, does this value, sorry, you want to clamp this value, actually. And we also want to, nope, I'm mistaken. I'm getting ahead of myself. That's the last step. We want to clamp the value. If this value meets, we have to consider this part we haven't done yet. We have another thing we need to include. And that is, are we in range to start slowing down? So what we're going to do is we're going to drag up here. We're going to do select float. And finally, we're going to plug this value into there. Are we in range of there? Yes or no kind of thing. Oh, you're not going to be pretty. All right, fine. Be that way. And we're going to clamp this value. So we're going to clamp this float. And we'll deal with the clamp in a second. Now it's closer this time to where we needed to be. All right, so that's the hint. This is the end of it, by the way. We have to work out this B value, and we have to work out this distance. So let's just make sure we understand what's happening here. So as we come in, we get our difference. We then multiply that with all of this lovely math here. That gives us the throttle input based on updates over time, which is why we have to cap it. Otherwise, they'll just keep getting higher and higher. And cars do have an upper speed limit. Or maybe the driver doesn't want to reach that upper speed limit and they want to drive at, say, a set speed. Or a set max speed. So, anyway, we get that number. We check if the car, is the object in front of the car or behind the car? If it's in front, we're passing that through. If it's behind, though, what do we pass through? Oh, sorry, if it's front. If it's in front or behind, we're passing that through. If, you know, or if we're over this distance, we don't want to change the speed at which we're going. However, if we are under a certain distance, we do want to change that speed. And so what we're going to do is we're going to drag off of here. And you know what, to make this easier, actually, we're going to drag that out a tiny bit. Push that over there a tiny bit. Put a reroute in. Move that reroute. And we're going to drag off this reroute a multiply. And we're going to pick a small number. So it's actually going to give it some throttle input, but it's going to be a relatively smaller number. We'll try a 0.5. It might actually have to be a 1. And we're going to plug that into the B so that we know that it has a lesser sort of value. And then we are going to cap this value at -10 as a minimum, or put the min as -10 and cap it with a max at +10. Again, this isn't speed. This is amount of input being put into the throttle. And we are going to, undo. Thank you. I wanted you to go back to where you were. All right, so we're going to set that there. And we're going to get that current throttle input. And we are going to apply it there. Okay, so now we can get the car from point A to point B. Let's test it out, see how it works. There's an error in the Marquee selection. Okay, let's go to our Marquee selection then. Find said error. Oh, whoops. I deleted something while I was looking for an error earlier. Let's just plug that back in. Really? If this happened to you, go back to the earlier part of the videos and put everything back in. I'm clearly going to pause the video and address whatever the whatever happened here. Alright, I will see you guys in a couple of minutes. Alright, well, I guess I should be thankful of some small things. As I was fixing this up and putting everything back in, I found a small error that we need to quickly address, and that's this. Just notice I've unhooked this pin now. We need to do what we did inside our controller when it came to a very similar setup. It isn't just now selected units, it's selected vehicles as well. We want to get the last index of it, and we want to know, is this last index less than or equal to 0? And it's if either of these conditions, so or, are true, so either or, then we want to go through this entire process. So let's compile. And now let's get back to where we were in the setup. So we were testing to see if our car can move, so we can select it. And let's set a nice little spot somewhere where something isn't going to spawn in. So let's set it over here. And look, there he goes. He's driving to the left. And he's going to keep going around it for a bit because we haven't told him what to do when we run into this situation. So I'm just going to watch that spin for a moment because that's just fun to watch. So he's reversing around it because he's near enough to reverse towards it. That reminds me, we didn't set a number actually for what he should do at that point. So let's go back to our ground vehicle here and let's set this number. And the number I typically use for this is, oddly enough, 5,000. I've tried different numbers. It just so happens that if you're going for longer distances, setting that 5,000 is useful. So let's just test this out, see what happens now. Too close for him to get to. Too close. Huh. Alright, those aren't too close. Why aren't you going towards them? Alright, let's go back to 0 for now, and I'll work out why my numbers aren't working between duplicates of the same set of code. I probably have just reversed something here, but I will take care of that in a minute. Let's set this back to 0.5, and actually let's test something real quick to make sure that's a valid number to have in there. Let's set the object behind the vehicle. There we go. He is reversing towards it. Alright. So what we need now then is to, what do we do when we're done moving? Alright, so we need to get our brakes in. And for that, first we're going to need a branch. We have our branch. And then think about our end goal as my usual approach here. We need, coming off here, a vehicle movement. And we're going to set brake input. And this is the same idea as a throttle input, someone stepping down now on the brake instead of the gas pedal. Well, this one's oddly enough relatively easy. There's a reason why we made this current variable. We're going to take that current input local. We are going to multiply it by 0.7 or 0.1. Actually, no, we're going to do it by, so I meant to, in my original version, to make it a stronger input. I meant to do 1.7. In the test file, I did it as 0.7, which makes it a weaker value. What we then is want the absolute value of this. So we don't want, if the car is in reverse, for the brake input to be a negative number. We want this always to be a positive. So absolutes, take a number, and if it's negative, it just, goes, it's positive now. It's not actually all it really does, but let's just think about it that way, because that's how we're using it. So our brake value will be our current input at a magnitude of 0.7 greater than its base value, which is that 1 there, as an absolute. So it's always going to be a positive number. Well, we need to know when we want to trigger this. And we want to trigger this. That might be why this isn't working right. Okay. I have, We will deal with that in a little bit. What we're going to do is we're actually going to take this same bit here, this current distance that we divide by our initial distance. We're going to copy it over. And I forgot I've changed this how I've done this previously, which is why it might not be working. We're going to do, is this less than or equal to? And we want it to be 50%, because these are floats. 50% isn't, 2, like it might be with an integer where you take, when you think about it as fractions, 1 over 2 or 2 over 4, it isn't that division where you get a value of 2. Where you multiply something by itself and get double that value. So this isn't where this is 5 and this is 10. It's going to give me a value of 2. In fact, it's going to give me a value of 0.5. So we want to know, are we at that halfway point? So 0.5 or less than. If so, start applying the brake. Yep, that's a very far away, I realize. And there are some other math we could do in here actually to make that 0.5 more realistic and reasonable. Well, reasonable, not realistic. In some cases, you probably would have severe whiplash, regardless. Get to as fast a speed as possible, and when you hit that speed, suddenly you're going to drop speed. Okay, so now we have that brake input set. We also then need to make sure that we have hit our current location. So we're going to have another branch. Oh, sorry, our target location, not our current location. We're always at our current location until the next tick goes by. Then we're not at that previous current location. We're at a new current location. And we're going to just copy all of this over. We're going to paste it here. We're going to plug that in right away. But this time we want to know, are we 1/10 away? Once we are 1/10 away, we need to set our parking brake or our handbrake. So we're going to set that to true, which is why we reset it in our move to location. Told you it'd be a while before we got there, or it'd be a bit before we add the explanation for that one. Sorry. And if we are there, what we want to do then is we want to reset all our brakes and throttle inputs. So I'm just going to copy both of these over, along with one reference to vehicle. Actually, no, I'm going to skip the reference to vehicle movement. I'm just going to copy those over. Still got the reference to vehicle movement. Delete the reference to vehicle movement. And I'm just going to plug these all into each other. I almost said daisy chain. I actually had to have someone recently explain to me, well, not recently, the last couple of years, when I was still in my late 20s, explain to me what a daisy chain actually was in reference to the flower thingamajigger people sometimes make. I'm just going to plug all of the targets into the singular vehicle movement just so I don't have to make that same call over and over again, and put a couple of reroutes in so it's pretty looking like a daisy chain. And again, meaning the childish version of it, not anything else, you sick people. All right, so we reset all our inputs except for the handbrake, which we reset elsewhere. Our throttle is now 0, our brake is now 0. And then what we need to do is we need to make our event dispatcher that we will use later on. Actually, no, we're going to skip the event dispatcher. We're not going to use an event dispatcher. We'll rewrite this for the later version. What we need to do, however, is we need to set our set timer by function name. And what we want to do is we want to set this this function itself, this update movement, which I'm just going to copy the name of and paste into here, because again, it has to be a spot-on copy to not loop anymore for 0.0 seconds. So it's not going to loop ever again until we activate it again by clicking. It needs to do one more thing. Let's get that reference we have up here out. Let's get that controller reference. And now, if you remember, we had a remove location decals or icons, depending on which version you went with. Remove location decals. We need to call that and fire that off. There we go. Now our vehicle is ready to go. So let's open this up. Let's hit play, and let's, there we go. I can't see the icon. He gets a location, he hits his brakes, he stops. Let's set one there. Actually, let's set it over here so we can change mid-go. There we go. Oh, he's not in a spot where he's happy about that location. So he's going to try to reverse towards it. So he's just going to be stuck in an infinite loop. Right, so let's clear that one, because that one's actually easy to take care of. I just want to see if I can get him to do it again, just to make sure it is what I think is happening. Yeah, it is. Okay. I am not being sadistic to the poor car. I am actually testing to see if it's what I think it is. So, the issue really is it's. Let's make this 0.05. This is the tolerance. If you think about our movement, so if we go to, that's our selection. Let's go to our player controller. Let's think about what we're really doing in terms of something that we know works and how it works. What we're doing is we're setting our acceptance radius, really. That's one way of thinking about what that variable is. So let's set it somewhere where it's, oh, he could easily reverse onto that one. Okay, so that was not a good choice for me. He's going to reverse onto that one too, isn't he? Yep. Fine, I see how it is. Set it slightly to your left there, buddy. Or right. I can tell my left from my right. Alright. Oh, he's going to actually... What is the actual distance there? Okay, I want to pause. We're actually going to resume. Oh my god, why did the camera not want to stay paused? Okay, we're going to pause. And what we're going to do is we're going to go into our car here. We're going to switch over to this. And not in scope. Awesome. So our initial value was 904 meters. Right. Our current distance is not in scope. Because one's a local variable. That's why. Alright. So, you know what we're going to do? Is we are going to simply print this to make our lives easier. This is what I did during the setup. In fact, actually, while I'm doing this, let me show you what the initial sort of look and how I debug this worked. There's the car. Hello, I was testing something. When I tell them to do something, I get all this data. And I had to pause to actually read the parts I want. There we go. Alright, so you can always use your debugs in that way. So what we're going to do is we're just going to plug that into here. And it's not going to be the duration, it's going to be the actual value that prints up. So when we go here, point two. Sorry, I'm moving this into a different window just so I can take a look at this better. So, we are setting it too small, so we need to set the value to 0.2. So, actually we're going to set it to 0.25. And I'm going to paste some stuff down here. By the way, what I just copied and pasted it in are is the same debug code you saw in the test file. We're gonna put a print here, and this will not be pretty. That goes into there. That goes into there. All right, and actually, I don't want the difference in this one. I want my current input. So we're going to plug that into there. So current throttle. Compile, play. And let's take a spot far away. Current throttle is set to 0.5. Okay. So that is where we're having this issue. We are getting this B value instead. So we want this, set this to 0. Still set to 0.5. All right. Let's set it to a value closer to what I'm used to this being. Throttle is 0. Alright, that makes me think there is something wrong with the throttle code itself. So we're going to spend another moment just going through the throttle code. We need to calculate and update the distance between our current location and the target location, which is our current distance. We then take our initial distance and we multiply it by this really small number. We add that to 1. That gives us our base value. Our base value is then raised to the exponent that might have explained so many various issues we were having. Let's try this again. There we go. And let's change this to 0.25. See what happens with that, because I'm curious about that low number we were using. All right, so let's back to the 5,000 I started with, because that is the number I recommend. And oh my god, sorry about that error. I will flag that in the video as a card. There we go. Awesome. And yep, came to a stop at the right spot. Awesome. So yeah, we have that working. We can get rid of that nightmare of debug crap I just put in. If you want to see me how I do that sort of debugging, I will gladly do a separate video on that. I will not do it in one of the actual videos like this. That said, we now clearly have a working car. Let's make sure our units work. And as I do this, if you like the video, go ahead and hit that like button. It gets that video out there so other people know about it. It helps, boost the channel's ratings. Also, if there's anything you want to see in this series, please leave a comment. Okay, so the physics is a bit off. We have to accept that that's going to happen. But please leave a comment down below. Again, these vehicles only got added in because someone requested it. In addition, and yes, the vehicle can go faster than the humans. I'm just setting short distance. In addition, if there's anything that you don't understand, you want more information on, ask about it in the comments. I'll see what I can do. And as always, I look forward to seeing you in the next tutorial where we'll get our where we'll 1, clean up that bug, and 2, get our units into the vehicle. Now we won't have a cool animation where we can see them in there. They'll just disappear. Remember, we have that is hidden boolean, and then we'll teleport them to wherever the car stops at. All right, that said, I hope you guys have a wonderful week.